If you've ever followed a big construction project, like infrastructure or even a large building,
Yeah.
you probably know that feeling.
Mm-hmm. That feeling of inevitability.
Yeah, exactly. That's going to run late, and it's definitely going to cost more than anyone thought. I mean, construction has always battled these huge challenges, right? Complexity, getting different teams to work together, those awful cost overruns.
Oh, absolutely. It's baked into the traditional process almost.
Yeah.
Our sources suggest, on big projects globally, something like 5, even 10% of the entire budget can just vanish into rework, fixing mistakes that weren't caught early.
It's just a real logistical gamble every time. Okay, let's unpack this.
Well, for ages, it was all static blueprints, maybe some basic modeling, and frankly, a lot of gut instinct.
Right.
But what we're seeing now, what the research points to, is a really profound shift. It's driven by artificial intelligence and advanced digital modeling coming together. And this combo isn't just tweaking things. It's genuinely reinventing how we build. And the key piece of tech here is the digital twin.
Digital twin, right. We hear that term floating around. But for construction, you're saying it's more than just like a fancy 3D picture.
Oh, much more. Think of it as a complete, living, virtual copy of the actual physical building or system.
A living copy, yeah. So our mission today in this deep dive is to really get into how these AI-powered digital twins are changing the game during the actual building phase, the execution. Two main things. First, how they tackle clash detection, stopping physical screw-ups before they happen. Okay, clash detection. Got it.
And second, how they help master schedule optimization, basically making sure projects finish on time and, crucially, on budget.
That dynamic part you mentioned, the living copy idea, that sounds like the core of it. It's not just a plan you make at the start and then, hope for the best.
Exactly. That's the foundation of this whole thing. The digital twin isn't just software you use for design and then put away. No, it's an active, simulated environment. It gives you this real-time, dynamic picture of the entire project from start to finish.
But how does it stay live?
Yeah.
That feels like the big leap from, say, BIM models we saw years ago. I mean, if the physical building is out there, how does the virtual one keep up?
Well, that's where the tech stack gets really interesting. It needs a constant stream of data flowing from the real world, the job site, back into this virtual sandbox.
Okay, like what kind of data?
We're talking about things like IoT sensors, Internet of Things sensors maybe embedded right in the concrete, tracking cure times or stress.
Wow.
Or daily drone flights doing scans, photogrammetry to update the model with what's physically been built, even laser scans, point clouds, tracking exactly where equipment and people are.
So instead of the project manager walking around with a clipboard once a day hoping to spot issues,
Right.
the digital twin is like this ultimate virtual supervisor. It's constantly checking the design, the should be, against the real-time data feed, the what is.
Precisely. That allows for what some sources call real-time compliance checking. You're doing your precise planning, execution, and monitoring all at the same time, basically.
So if a worker starts putting up, say, ductwork just slightly off.
The twin flags it instantly because the scan data coming in doesn't match the model data for that location. So potential mistakes get caught right away, not, weeks down the line when the drywall's going up and suddenly nothing fits. That kind of instant feedback. Yeah, that feels like a massive step forward.
Okay, let's zoom in on one of the big problems this helps solve, preventing things from literally running into each other, what the industry calls clash detection.
For anyone listening who maybe hasn't been on a complex site, why is a clash such a big deal? Seems simple? No. Well, it sounds simple, but the implications are huge. A clash is basically where two or more parts of the building systems, structures, are designed or installed to occupy the exact same space.
Right.
Think about a really dense building, like a hospital or a lab. You've got the main structure, then layers upon layers of complex systems, big HVAC ducts, electrical conduits, plumbing pipes, fire sprinklers, maybe even specialized gas lines.
And all designed by different engineers, probably using different software, right?
Often, yes.
Yeah.
And historically, trying to manually overlay all those separate designs on 2D drawings or even early 3D models, it was almost guaranteed you'd miss things. You'd find a huge pipe scheduled to go right through where a steel beam needs to be.
And finding that out after the beam is in place.
It's a nightmare. If those clashes aren't caught until construction starts, you get this cascade effect. Work stops immediately. You have expensive specialized workers just standing around. Then comes the costly rework, maybe cutting into concrete, rerouting steel, pairing out perfectly good systems that were just installed.
The cost must multiply incredibly fast.
Oh, easily. Fixing a mistake on-site can cost like 10 times more then fixing it virtually during the design phase.
Yeah.
Plus, the delays, the safety hazards it can introduce, it's a massive drain.
Okay, so how does AI make this better? Is it just smarter geometry checking than before?
It goes quite a bit beyond just geometry. What's fascinating here is how AI essentially moves that whole error correction process off the physical job site and into the virtual realm much more effectively.
How so?
The AI models are trained on vast amounts of data from past construction projects. Not just the successful parts, but crucially also where things commonly went wrong. Common failure points.
Ah, so it learns patterns.
Exactly. It uses sophisticated spatial analysis algorithms to automatically sift through potentially millions of data points representing all the components. It's not just asking, do these two shapes overlap?
It's doing more.
Yeah, it can factor in things like installation sequence, required clearances for maintenance, material properties. It can even perform predictive risk scoring.
Predictive risk scoring. So it tells you which clashes are the most dangerous.
Precisely. Instead of just giving you a list of, say, 500 minor clashes between some wiring and a small pipe, the AI might highlight the 5 critical clashes, maybe ones involving major structural elements and complex mechanical systems that are due to be installed soon.
Okay, that makes sense. Prioritization.
Right. And that predictive ability lets the project team focus on fixing the big, costly problems in the virtual world, first tweaking the design models long before anyone picks up a tool on site. That's the key to minimizing those expensive mistakes and really boosting efficiency.
Let me just push back slightly here, playing devil's advocate. This sounds incredibly powerful, but also complex.
Yeah.
Expensive to set up. Is this really only for the giant billion-dollar mega projects right now?
That's a really important question, the accessibility question. And the sources do suggest that, yes, initial adoption was heavily focused on those huge projects.
Yeah.
Airports, massive infrastructure, where avoiding even one major foul-up justifies the investment very quickly. But what's happening now is that the cost of the underlying tech, cloud computing, specialized software, the sensors, it's all coming down. It's becoming more scalable.
So smaller firms, mid-sized projects, they can start to use this too.
Increasingly, yes. The value proposition shifts a bit. Maybe for a smaller project, it's less about preventing one catastrophic clash and more about consistently reducing smaller delays, improving how subcontractors coordinate, smoothing out the workflow. The ROI, the return on investment, comes from those cumulative efficiency gains, whatever the project's size.
Okay, that's good to hear. Because catching the physical mistakes, the clashes, that's critical. But it's only half the story, isn't it? You could design and build a clash-free building, but if it takes twice as long as planned, you're still losing money.
Absolutely. Which brings us nicely to that second key function you mentioned, schedule optimization.
Yeah.
Yeah, if clash detection handles the what and where, schedule optimization tackles the when. And managing construction timelines. Honestly, it's such a delicate balancing act.
A big project might mean juggling thousands of different tasks, all interdependent. Our sources really highlight 2 tricky areas where AI in the digital twin makes a huge difference. Managing material procurement just right and coordinating labor deployment efficiently. It sounds almost like military logistics sometimes. If one critical component, one specialized piece of equipment gets held up.
The whole front line grinds to a halt. It's a great analogy. Think about building, say, a new hospital wing. You need the basics like steel and concrete, sure. But you also need highly specialized gear, maybe MRI machines, sensitive lab equipment.
Right, stuff with specific needs.
Exactly. Some might need specific climate control during shipping and storage. So if it arrives 3 days early, maybe you've got nowhere suitable to keep it. If it arrives 3 days late, the expert installation crew you booked is sitting idle, costing you money. The complexity just ramps up incredibly fast.
So how does the AI help the project manager, the conductor of this orchestra, keep everything in rhythm?
The digital twin is constantly pulling in data, not just the project plan itself, but also external factors. Things like real-time supply chain information, weather forecasts, even data on labor availability in the region.
Wow, okay.
The AI then uses predictive modeling, essentially machine learning, to forecast how all these little variables might impact the final completion date. It's not just managing the schedule, it's constantly stress testing it.
So let's say the AI sees that a crucial shipment of, I don't know, special curtain wall glass is likely to be delayed because of shipping congestion. What happens then?
It flags that potential delay instantly. But crucially, it doesn't just say problem ahead. It runs simulations to figure out the best way around the problem.
Okay.
It might suggest, for example, okay, let's resequence the interior work, focus on areas that don't need that glass yet. Or maybe let's accelerate task X by bringing in that other crew who just finished early. By constantly analyzing all this data, it predicts those bottlenecks and delays before they actually happen, letting the team react proactively.
That really shifts scheduling, doesn't it? From constantly reacting to problems, putting out fires, to being much more proactive, predictive even.
Exactly right. Using AI lets teams genuinely optimize workflows, allocate their resources much better, and just keep the project relentlessly on track. The difference this makes, it's often the difference between finishing on time, on budget, and slipping 6 months late with massive cost blowouts.
And here's where it gets really interesting. The speed. You mentioned the real-time data feeds earlier. Because the digital twin is always being updated site progress, supply chain info, the schedule simulation isn't static. It allows for almost instant updates and adjustments.
Yes.
So the teams aren't working off a plan printed last Monday. They're seeing a constantly optimized path forward based on what's happening right now.
It dampens those ripple effects from small problems. Traditionally, a minor delay in plumbing might hold up the drywall team for 2 weeks just because nobody updated the master schedule fast enough or figured out the knock-on effects.
Right, simple communication breakdown.
Yeah. But in the digital twin environment, that adjustment, that resequencing happens almost instantly. The system might automatically see the drywall crew is freed up and reallocate them to another part of the building where they can be productive immediately. No wasted time.
This has been genuinely eye-opening, a real deep dive into how tech is shaking up one of the oldest industries around. So let's pull back a bit. So what does this all mean? What's the big picture takeaway for people listening?
Well, I think there are two really clear takeaways for you, the listener. Fundamentally, integrating these AI-powered digital twins brings a new level of professionalism and predictability to construction. It lets teams first drastically reduce errors by finding those potential clashes predictively in the virtual world.
Okay, fewer mistakes.
And second, it helps them enhance overall project efficiency through that dynamic, real-time schedule optimization we just talked about. Fewer delays, better resource use.
It really sounds like moving away from just managing crises towards genuinely preventing them. The promise seems bigger than just, better buildings delivered slightly faster.
It really is. The sources we looked at describe embracing digital twins today,
Yeah.
not just as like a tech upgrade. They call it an investment in the future of construction.
An investment.
Yeah,
Yep.
one that fundamentally changes the risk profile of building things.
Yeah.
It improves stability. And if you think about the wider economy, this could have profound implications.
How so? Well, think about it.
Yeah.
If this technology becomes widespread, if construction costs start to stabilize, if major project delays become far less common across the whole economy, what are the downstream benefits of that?
Yeah, that's the really big question, isn't it? If we can significantly lower the risk, the logistical risk, the financial risk of building essential infrastructure, housing, everything, what does that kind of stability mean for things like inflation, maybe even interest rates, the basic cost of putting a roof over your head? The digital twin isn't just about construction efficiency. It could potentially ripple out and stabilize some major economic forces. Fascinating stuff to think about.